Okay, so today we're doing Lewis structures. The syllabus outcome for this is investigate the difference between ionic and covalent compounds through using nomenclature, valency, and chemical formulae, including Lewis dot diagrams. So Lewis structures and Lewis dot diagrams are the same thing, just a slightly different name. They can also just be called dot diagrams. So have a go at the revision questions at the top of page 96. If you've done them, we're going to go on now. So intermolecular forces are forces acting in between molecules. Okay, so remember, it's not the interactions within the atom itself, it's the molecules to molecules. It includes dipole-dipole interactions, dispersion forces, and hydrogen bonds. The strength is dispersion forces are less than dipole-dipole, which are less than hydrogen bonds. And intermolecular forces affect the physical properties. So having a look at Lewis structures, remember also called Lewis dot diagrams. Created by Gilbert Lewis in 1916, Lewis structures were a way to show the structural formula of simple compounds. You can use them for more complex ones, but we do have other ways to do that. This is easiest for just simple, basic compounds. The Lewis structures, they show valence electrons as dots and covalent bonds as lines or pairs of dots. We can also draw them as like twin X's, stuff like that. Now, each covalent bond contains 2 electrons. That's why I did 2 X's at the top there. So let's have a look at the dot structures of the individual atoms before we start combining them into molecules. So this is a good table. It shows us most of the main ones that we'll be using. Okay, so our group 1 atoms all have that 1 valence electron. Group 2 have 2 valence electrons, so on and so forth. You know, carbon's got 4, fluorine's got 7, neon's got 8. Okay, so these are the only ones that we're going to need to know. If you're not sure how to do it, remember we had a look at that table a few lessons ago where it's group 1 has the 1, group 2 has 2, group 13 has 3, 14 has 4, and it just keeps adding on until the end. And we just ignore the transition metals and the lanthanides and actinides for this stuff. So, yeah, like I just said, no D block, no F block. So no transition metals, no lanthanides or actinides. We're mainly just going to keep it to the simple ones. In fact, I don't know if we'll go anything outside of sort of maybe these ones, but be prepared to just in case. So Lewis structures, they'll show how the valence electrons are arranged among atoms in a molecule. The Lewis structures relate back to the octet rule, where the most stable elements compounds have a full valence shell. Shared electron pairs are covalent bonds and can be represented by 2 dots or 2 crosses or by a dashed line. Now, the rules. What are the rules with Lewis structures? So firstly, we make the atom wanting the most bonds the central atom if there's more than 2 atoms total. So something like NH3, N is going to be our central atom and everything's going to be bonded around it. We need to draw the proper number of dots around each atom. And we join atoms on the outside with the central atom using electron pairs, obeying the Honk rule, which I'll get to on the next slide. And then from there, you need to make sure every atom has a full valence shell. If not, you might have to add more bonds or change around your bonds. Okay, so you need to make sure that for hydrogen and helium, you've got 2 electrons in your outer shell. For everything else, you've got 8. There are some exceptions I'll get to in 2 slides time. Okay, they're the main ones. So 2 for hydrogen and helium, 8 for everything else. Now the Honk rule. Honk is hydrogen, oxygen, nitrogen, carbon. Now if we remember these, it tells us the number of bonds that each of these things can produce. So hydrogen and halogens, so the H in Honk, form 1 covalent bond. Okay, so we very rarely get anything more than a single bond to fluorine, chlorine, bromine, iodine, etc. Oxygen can form 2 covalent bonds. Now it can form a bond to 2 separate other atoms, as is the case with H2O, or it can form a double bond. So as is the case with carbon monoxide, it's actually a double bonded to carbon. Nitrogen forms three covalent bonds, so it could be three single bonds, a triple bond, or one double and one single. Okay, so it can be arranged in any of those orientations. And lastly, we have carbon and silicon. That's the C. They form four covalent bonds, so we can have it in all sorts of different ways. Four single bonds, two doubles, a triple and a single, or a double and two singles. Okay, as long as it adds up to four complete bonds, that's fine. Now, the exceptions to the rule. Atoms in the third period and below sometimes disobey the octet rule. So generally, past the third period, things get weird because we're introducing d orbitals and f orbitals and all this sort of stuff that makes things a bit screwy. So what happens is things like sulfur and phosphorus, they can actually have 10 electrons around them. They're pretty happy with that. Basically, it just fills up the next s block. Okay, so rather than having a full octet, it's got the full octet and two s electrons. So that's fine for sulfur and phosphorus. So we'll practice with these. However, looking at past exams, I haven't seen them really show up. Okay, generally the Lewis dot structures are a bit easier, but be prepared because it's there in the syllabus. It could happen. Now the other exception is boron. Boron can also disobey the octet rule. It's a really weird one. It can have 6 around it, so it's happy just being having those 6 electrons rather than the full 8. Okay, I know there's a lot of rules, but let's start putting them together and see if we can figure it out. So the first one is to draw the Lewis dot structure of water. So the first thing we want to do is figure out, draw each atom with the correct number of dots around it, and maybe list down how many bonds it can have. So hydrogen just has the 1 dot. We've got 2 of them. We also have an oxygen with 6 around it. Okay. Now we also know from the Honk rule that oxygen can have 2 bonds, hydrogen can have 1, and that's each. Now, we make the atom wanting the most bonds the central atom, so in this case it's oxygen. So oxygen wanted 2, so we're going to put that in the middle. We're going to put the hydrogens near it like that. And then we're going to join the atoms on the outside with the central atom using electron pairs. So ensure you follow that Honk rule. So I'm going to do it like this. So we're going to bond those two. We're going to make them into covalent bonds like so. Okay. And so that's our structure of water. Now, the last of the rules is to make sure we've got the right number of valence electrons. So let's have a look. Double check the number of electrons around each atom follows the octet rule, including the bonds into counting. So here, because we have 2 electrons in each bond, okay, and the electrons from the bond count towards the atom that it's bonded with. So here, oxygen has 8 electrons. Okay, so tick. That fulfills the octet rule. So it's all good to go. Having a look at the hydrogens, each hydrogen has 2. So remember, hydrogen is one of those exceptions that can have 2 in its outer shell. And so that's correct. So we've got the right number of electrons. That's the right Lewis structure for water. Now, example 2. Draw the Lewis structure of ammonia. So first step, draw each atom with the correct number of dots. So we have hydrogen. This time we have 3. We also have nitrogen that should have 5. You can also go back and check the Honk rule. So HON, N is third, so it comes with 3 bonds. And each of the hydrogens has 1. So we arrange it with, well, nitrogen can have the most bonds, so we arrange it in the middle. We put the hydrogens around it. Sorry, yeah, that nitrogen should have 5. I just stuffed up the animation a bit. So yeah, we have 3 hydrogens around it. And then we want to start making pairings. Okay, so hydrogen wants to form 1 bond, Nitrogen wants to form 3, so I'm going to form them like that. Now the reason I've drawn it this way is to make it easier for you to see, but once you do it a few times, you start to get a feel for how they're going to be arranged. So that's our Lewis dot structure for ammonia. Okay. We double check the number of electrons around each atom that it follows the octet rule. So we include the bonds. So nitrogen has a lone pair of electrons. So there's 2 electrons at the top, 3 bonds for a total of 8. Each of the hydrogens has 2. Okay, so each of them has a bond with 2 electrons. So that's good to go. So have a go at drawing the Lewis structures of these compounds. So remember, draw the dots first, try to find which one's going to be the central atom, draw it around, and then make some bonds. Okay, now that you're back, here's the answers. Sorry, I forgot to put in the answers. So CH4, it's going to have 4 around it. Each hydrogen's going to have 1, like so. We then form bonds through there, like that. So that's going to be our Lewis structure. We double check. Carbon has 8 around it, and each of the hydrogens has 2. H2S, so H, H, S, form bonds like that. Okay, so that's our structure, just double checking. So sulfur has 8, so it's all good. Hydrogen has 2, the other hydrogen has 2, so that one's okay. And lastly, CO2. So if we have CO2, we have 4 around that one, 6 around that one. Okay. So if we form a bond over here and one over here, okay, we check around each atom. So that one's got 7, that oxygen's got 7, and the carbon has 6. So it's not enough. Okay. So what we have to do is draw it slightly differently. So I'll redraw it like this. What's actually going to happen is we're going to get what we call double bonds. So we're going to get one bond forming here and another bond forming here. And same over here and over here. So remember, if we don't have enough valence electrons to fulfill the octet rule, it means we probably haven't put in enough bonds. So now that we've got this, we can actually see that, oh hey, this oxygen now has 8, this oxygen now has 8, this carbon now also has 8, so that one's good. Okay. Now, the summary for today, Lewis structures were a way to show the structural formula from simple compounds. Lewis structures show valence electrons as dots, covalent bonds as lines or pairs of dots. And after creating a Lewis structure, you need to ensure that the number of electrons around an atom follows the octet rule. And that's all for today. So please go on to the questions at the top of page 100 and see how you go.